Okay, so we're going to be covering this trigonometric question or trigonometry question. So the question is saying, by first finding the length of BD, this line, show that 20 sine square theta is equal to 9 cos theta. So for this question, you can see that, let's first count how many triangles there are. So we can count that here. This is one triangle. This entire thing. This is one triangle. This is the second triangle. And then if you ignore the line BD, you can also see that there is a third larger triangle, this. But we won't be needing that in this question, so don't worry about it. I just want you to recognize that there are two triangles here, this and this. Okay, let's move on. So before we dive into this question, let's first revise trigonometric identities. So we need to know that sine theta is equal to perpendicular hypotenuse. Actually, I'll clarify what I mean by perpendicular, what I mean by base, and what I mean by hypotenuse. By perpendicular, I mean the line which the angle points to. Look at my arrow. By hypotenuse, I mean the line which the 90-degree angle points to. And the remaining side is the base. So since we've got that confusion cleared, let's move on. So sine theta is equal to perpendicular hypotenuse, and cos theta is equal to base over hypotenuse, and tan theta is equal to perpendicular over base. We can also write tan theta as sine theta over cos theta. That'll come in handy later, but for now, let's just focus on these trigonometric identities. Just focus on them as is right now. Let's memorize them. Okay, we've got them down. So the first step in solving this question, we need to find the length of BD. First, let's ignore one triangle and just focus on the other one. So I'm going to focus on this triangle first. Triangle BDC. I'm going to be coloring it with blue to show that this is the triangle we're going to be focusing. The other triangle, triangle BAD, the one with 9 on it, we're not going to be focusing on that for now. Let's just leave it aside for now, and let's pretend as if this is the only triangle in the question. So this is a 90-degree triangle. And because of it being a 90-degree triangle, we can apply trigonometric identities here. So trigonometric ratios. Yes, trigonometric ratios. We can use trigonometric ratios here. Sine theta is equal to perpendicular over hypotenuse. Just let's first find out what the perpendicular is, what the base is, and what the hypotenuse is. So the line which the angle points to, that's BD. So BD is equal to the perpendicular. What's the hypotenuse? The line which the 90-degree angle points to, or the right angle points to. That's 20. So the hypotenuse is 20. So since we know the perpendicular, we need to find the perpendicular, and we know the hypotenuse. So the perpendicular is the unknown, we know the hypotenuse. Which one of these equations uses one known and has the other unknown? We can cancel, we don't need to use cos here because that's base over hypotenuse. We don't need to know base, we know the hypotenuse. And we can cancel tan theta because we don't know the base, nor do we know the perpendicular. So we're only left with sine theta. So let's apply sine theta. So perpendicular is the line which the angle points to, BD. So sine theta is equal to BD, and the hypotenuse is 20. So 20 sine theta is equal to BD. That's one value of BD. So this is not enough to come to a conclusion. We need to find another value of BD, because I have to somehow make this to this, and that's pretty much impossible. I have to introduce another value of BD so that I can come to a conclusion here. So now that we've already found our value, that's one value of BD. Let's find the other value of BD. How do we find that? Ignore triangle BDC and just focus on this triangle now. Completely forget that the triangle BDC even exists for a second. And just look at triangle BAD. What are the angles that we know? Okay, so we know that there's a 90-degree angle, so we can use these trigonometric ratios. We don't know this angle, and nor do we know this angle. I'm kind of stuck here. There's a solution. So let's focus on this triangle again. It's a bit confusing, but let's jump right back to this triangle BDC. Let's jump back here. So we know that the sum of angles in a triangle is 180. Meaning if we add up all the angles in a triangle, that's going to give us 180. So that means this is 90 degrees, this is theta, and this is the unknown. Let's label that as y for now. So I'll write it over here. Y is equal to, or actually, no, sorry. Theta plus 90 plus y is equal to 180. Because we know that the sum of angles in a triangle is 180 degrees. Let's move 90 over here, or just subtract 100. Let's subtract 90 from 180. So theta plus y is equal to 90. Y is equal to 90 minus theta. So we know that this specific angle here, this angle, 90 minus theta. Or I'll redraw the triangle here. This is 90 minus theta. 90 minus theta, and this is 90, and this is... This software is just so annoying. This is theta. Okay. And let's focus on the other triangle now. Let's look at the other triangle. So we know that this entire angle, this entire thing, the third triangle that I was referencing in the very, very start of the question, this entire big triangle that I was, mentioning at the start, that is very, very off looking right angle triangle. But I guess that goes. This massive triangle, right? The third larger triangle that I was referencing. So we know it's already drawn in the question, the diagram. Look at this square type thing I drew over here. That symbolizes 90 degrees. So that shows that this angle plus this angle gives you 90 degrees, this thing over here. So let's now label that as z, because that's another unknown. So that means 90 minus theta plus z gives you 90. So 90 minus theta plus z gives you 90. Move 90 over there, and that subtracts, that becomes 0. So minus theta plus z is equal to 0. Z is equal to theta. So we've basically found out that this angle over here, I'm going to use a different color to just make it easier. This angle specifically over here, this one, this is also equal to theta. Alright, so let's do the other procedure, right? The basic procedure we were following since the start of the question. Let's ignore the other triangle. Just focus on one. So we know that this specific angle, that's theta. I want you to just focus, just lock in on this triangle over here. Completely ignore the other triangle. Just focus on BAD. Ignore the other triangle. For ease, I'm going to redraw BAD over here, because it's a bit messy after all the working I've done over there. So I'll redraw it here. So let's redraw triangle BAD. This. We know that this angle is theta. If you don't understand anything, please comment. This is 90 degrees. We don't need to know this angle. This is 9. This is BAD. So to come to the conclusion, to find this expression, I need to find the other value of BD. So I've already found out what values I'm looking for. I'm trying to find this value. I know this already. So let's identify with the perpendicular, the base, the procedure. So this is a perpendicular. This is the hypotenuse. And so this BD, this whole thing, that's a base. Because that's the only side left. We know BA is a hypotenuse. We know AD is a perpendicular. So that only leaves BD as a base. Okay, so we know the perpendicular. We need to find the base. Which trigonometric ratio, hint, it's over here, which trigonometric ratio incorporates both the perpendicular and the base? That's tan theta. Okay, so let's write tan theta. Tan theta is equal to perpendicular over base. What's the perpendicular? 9. What's the base? BD. So tan theta is equal to 9 over BD. And I can move BD over there. move tan theta below. Okay, so that's the other value of BD. So I found, this is the first value that I found. This is the second value that I found. Now BD cannot assume different values, right? That's obvious. That's just common sense. When you have one line, one person says it's 1 meter long. It's 1 meter long. Like it doesn't just magically change values. So BD must of course be equivalent to BD, right? That's just common sense. BD is equal to BD. They must be equivalent to each other. So I move this over here and I move this over here. So 20 sine theta. Both my values of BD should be equal to each other. This is where sine over cos theta. Remember when I wrote this over here? This is where it comes to play. Okay, so 20 sine theta. Let's replace tan theta with sine theta over cos theta. Okay, so there's this general formula that I want you to know. A over B over C. If you encounter this, you can rewrite this as AC over B. Right? Because if you want me to really get into like how this works, we can, you know how we're going to say 2 over 4, that's basically the same as saying 2 divided by 4, right? So let's just remove that. We can get that. So we can say that this whole fraction thing that we wrote, that's A divided by B over C, A into, since when we divide fractions, we take reciprocal. So that's C over B. So that's AC over B. Same thing we wrote over there. But there's no need to do this long drawn, like proving every single time you encounter it. You can just straight away write AC over B. The examiner, like, he assumes that you know AC over B, this whole formula. So there's no need to, like, go the extra mile and then divide it and then show how you came to the conclusion that's AC over B. I'm just doing it to show you how how we managed to derive this formula. So A over B over C, that's AC over B. I want you to look back to 9, this monstrosity that we wrote over here. What's A? I'll use a separate color. What's A? 9. What's B? Sine theta. What's C? Cos theta. So you can rewrite that as AC 9 cos theta over sine theta. And let's move it over there. And voila, that's our answer. Leave a like if you understood. If you didn't, leave a comment and I'll reply to you, and I'll even make a separate video if it warrants that. Otherwise, I'll try my best to explain in the comment section.